Welcome to Unit 1, Lesson 2, the metric system. Today's learning target is I can convert between metric units. Let's get rid of this little message and let's get going. Okay, metric system is used by almost 99% of the world, and they measure nearly absolutely everything with the metric system. There's only 3 countries in the entire world that don't use the entirety of the metric system. They may use bits and pieces. They may define their measurements in terms of the metric system, but they don't use the whole thing in its entirety. That would be the United States, Liberia, and Myanmar. So, because so much of the world uses the metric system, scientists all over have decided that they are going to use the metric system as their standard unit of measurement in science, regardless of the country. And the reason for this is so that everybody's measuring the same stuff in the same units. It's very easy for different scientists in different parts of the world to communicate their thoughts, ideas, hypotheses, their findings, because we're all measuring kind of in the same way. So there's different types of measurements. And just like there's feet and pounds and gallons, we have all of that same stuff in the metric system. It's just given a different name, basically. The sizes obviously are going to be different. A meter is not equal to a yard exactly, but they're kind of close. The way that you'll know what is being measured is by use of a suffix. It's the thing that comes at the end of the word. So if you think of the English language, for instance, if I said, I'm singing, you would know that I'm singing right now because of that ing ending. If I say, I watched TV, that ed would tell you that I watched TV at some point in the past. The suffix in the metric system for measurements is going to tell you what's being measured. If you were to measure 5 meters, you know that this is measuring length or distance. That's how you know. If I said 500 Kelvin, you would know I was measuring temperature. If I said 800 seconds, you'd know I was measuring time. After getting the type of measurement, we are going to get the relative size of the measurement, and we get that by using a prefix. There are more prefixes than what I have listed here: nano, pico, micro, mega, tera. Think of computers, for instance, how they measure data on a computer. Those are metric units. They're just bigger than the ones listed here. These are the first few, and those are the ones that we primarily need for chemistry. Each one of these prefixes is going to be based on a multiple of 10. So as you can see, we're going 1, 10, 100, 1,000. The next one would be 10,000, etc., etc. We can also go in the opposite direction, where instead of getting bigger, we're getting smaller. Here we're going 1/10, 100th, and 1,000th. There's ones even tinier than those. So the prefix is just going to kind of give you a ballpark of what type of measurement we have. So if I said, I don't know, an elephant is, I have no idea how big an elephant is, but let's just say it is 10,000 kilograms. You would know that that elephant is going to be big. If I said an ant had a mass of 100 milligrams, you would know that milli means that I'm measuring something small. If I made something up and said a Gerbil flob was 100 kilograms, you would say, wow, whatever a Gerbil flob is, it must be pretty big. That's how you would know, based on the prefix, essentially. Each prefix is given a symbol the same way feet is FT or pound is LB. Each of these prefixes is going to get its own symbol. So kilo is K. And if we pair that with M for meter, we would get kilometers or kilometers, as some people say. A capital H would be hecto, just like this right here, representing the number 100. And capital L for liters. A hectoliter would be equal to 100 liters. And this is just how we abbreviate it for writing things quickly and succinctly. When I have a letter all by itself, it is going to fall in the category of the base units. So liter, meter, gram, capital K for Kelvin, MOL for mole, not a great example, but for the purposes of chemistry and what I'm teaching right now, that would be just our letters all by itself. M is for milli and G is for grams. Put them together, you get milligrams. I think you're seeing it at this point. If I were to have 5 kilometers or 5 kilometers, that would mean that I had 5,000 meters. 5 kilo is 1,000, and then meter is measuring distance. So I'm measuring a distance of 5,000 meters. Elsie. Yes. Busy? Yes. Sorry, interrupted. So if I had a distance of 5 centimeters, then I would have 5/100ths of a meter, because centi represents the 100th. So I can convert between my metric units somewhat easily. There's a harder way to do it. I like the easy way. This number system is based on the number 10. Each of these prefixes is based on the number 10. So we could really say that it's based on the decimal system. If I were to convert 3.44 kilometers into meters, I would do that by multiplying by 10 3 times, which is essentially the same as multiplying by 1,000. And that is because kilo represents 1,000. There's a far easier way to do this, and that's what I'm going to teach you today. The easy way is remembering this silly sentence. King Henry drinks unusually delicious chocolate milk. So here we have king is for kilo, Henry is for hecto, D for deca, etc., etc. We need to keep all of these in order for this purpose. We need one letter or one term for each of the place values so that we don't wind up skipping more than one place at a time. If I were to convert, let's say, 1.24 meters into centimeters, I would be multiplying by 10 2 times. I'd be multiplying by 100. I could do that same thing here to get to 100th up to 1, I'd have to multiply by 100. Or to go from here to here, I'd multiply by 10, and then from here to here, I'd multiply by 10 again. So if I were to go from meters into centimeters, I would have to multiply by 10 2 times. I like to do it this way. King Henry drinks unusually delicious chocolate milk. If I go this way, I'm multiplying. If I go this way, I am dividing. And for each jump, it's by 10, just like on the place value chart. Or in the decimal system, it works the same way. So if I were to convert meters into centimeters, I would look, meter is going to fall into my unit area, and I am going to jump 2 times to the right. So what I'm going to do is I'm going to take my decimal and I'm going to move it 2 times to the right. When I do that, I am going to get 124 centimeters with my decimal at the end because I have physically moved it. So if I had a string that was 1.24 meters long and a string that was 124 centimeters long, they would be exactly the same length, the same way that 1 foot is equal to 12 inches. It's the same thing. Now, I could do that same thing here if I were converting from meters into millimeters. To do this, I would take, again, I'm going from meters and I'm trying to jump out to milli. So I have to go 1, 2, 3 places to the right. I'm also going to move my decimal 3 places to the right. When I do that, I wind up with this empty jump, as I like to call it. And I'm going to give props to Mrs. Mitchell, my 4th grade teacher. She taught me how to multiply by singing a horrible jingle that has stuck with me for the last, I can't even tell you how long years. 0 the hero holds the space so all the other numbers can stay in their place, right? I am going to put a 0 into this empty jump so that I can keep all of my numbers where I want them. So in moving my decimal 3 times to go from meters to millimeters, I'm going to wind up with 1,240 with a decimal millimeters. That's it. It's that simple. If you can remember, King Henry drinks unusually delicious chocolate milk, then you are going to be just fine because you will have a block for each one of the jumps. Okay. Now this one, we're going to go from right to left instead of left to right. It's no different. Okay. The thing here that I need to point out is that we have DG. This is decigrams. And you may say, how the heck do you know that's decigrams? I thought it was decagrams. Well, the way that you would know is because if you go all the way back here, we would see that decagrams represents 10 and decigrams represents 0.1 or 1/10. Deca is the bigger number, so it got the capital D. Decigrams is a smaller number, so it got a lowercase d. Okay. That's how we know. So this is a lowercase d telling me I need to go to small d or to deci. So what I'm going to do is I'm going to move my decimal to get from deci to kilograms 1, 2, 3, 4 times. Each time I would be dividing by 10 if you wanted to do it mathematically, which is 10, 100, 1,000, 10,000. I would take this number and I could divide by 10,000, or I could do it the easy way and 1, 2, 3, 4. Move my decimal 4 times to the left. When I move my decimal 4 times to the left, I am going to get 1.2985 kilograms. Easy peasy. That's the whole thing. I'm going to show you 2 more examples if you're interested. Otherwise, that's the end of the learning. If you want a little bit more practice, keep watching. Otherwise, make sure that your note sheet is filled out and have a great evening. So here we go for those wanting to practice. If I were going to take, let's say I had a lab experiment and the procedure said I had 0.25 liters of a substance I needed to use, but I can't measure. That is an equal sign. This is the ugliest equal sign of all time. I don't have a tool that measures in liters in my lab. So what I need to do is I need to do this in milliliters because that's what I have. So I have to take this value and I have to convert that into liters. Well, how exactly are we going to do that? I'm going to remember that silly, stupid sentence. King Henry drinks unusually delicious chocolate milk. L, the liter, falls into unit, and I'm trying to get to milli, which means I need to move 1, 2, 3 places to the right. I'm going to take my decimal, and I'm going to move it 1, 2, 3 places to the right. When I do that, I wind up with an empty jump, which means I need to add in a 0. And I'm going to put my decimal at the end right there. This is going to give me 250 with a decimal milliliters. Boom. That's the whole thing. That's the whole thing. If you can remember this, you will be just fine. Now, my students have reference tables that do not give them this KHDUDCM. It gives them scientific notation, and it'll say that kilo is, I believe, 10 to the third, and it tells you that milli is 10 to the negative third, and I don't like scientific notation. I don't like fractions. I am not about that. I would so much rather use the KHDUDCM method. So my students take this in the green box and write this on your reference table. If you don't do it now, we're doing it in class tomorrow. You are going to take this and write it on your reference table so that you have it in your brain. It helps you to practice it. The more you see it, you won't have to put any effort into memorizing it. It'll just kind of happen by accident. That's what we're going to do. So moving right along, I'm going to do one more example and that'll be it. Let's say I needed to take, I don't know, let's do a crazy one. We just went from, what did we do? Liters to milliliters. That's going down the scale. I want to go up the scale. Let's say that I had Oh, where's my pencil? Let's say I had 3,294 centigrams and I needed to convert that into kilograms for whatever reason. It doesn't matter. We're just imagining here. So I'm going to say King Henry drinks unusually delicious chocolate milk, and I'm going to figure out how many times I got to move my decimal. So I'm going to move from centi to kilo, and I'm going to go 1, 2, 3, 4, 5 places to the left. In this number, my decimal is back here. I'm going to move my point 5 places to the left. 1, 2, 3, 4, 5. And in doing that, I need to plug in a placeholder 0. So my final answer would be decimal 03. That is, again, a super ugly. I'm going to write it over here. That is going to be decimal 03294 kilograms. And it's just simple as moving the decimal as many times as you jump on the scale. And if you can remember the little hack, the little cheat, then everything will fall into place. You just have to, still not working. You just have to remember that King Henry drinks unusually delicious chocolate milk and jump the same number of places in the same direction to get your answer. Okay, we will be practicing more in class. That's it. If you have any questions, feel free to leave a comment. If you need immediate help, get me on Remind. If you need to rewatch, feel free. That is all. Have a great night.